Analog to digital converter. In electronics, an analog to digital converter is a system that converts an analog signal, such as a sound picked up by a microphone, into a digital signal. In other words, analog to digital converter is any device for changing analog signals into digital transmission. For example, recording someone singing onto a CD. The pressure waves in the air, produced by the vibration of the person's vocal cords, are analog in form and continually vary in strength, within a certain range of values. The recording equipment samples this, continually varying information at discrete time intervals and converts it to digital form. Analog to digital converters are used in industry to convert environmental variables, temperature, pressure, density, speed, and so on, that vary continuously over time, to digital information, which can then be analyzed using computer programs. Nonlinearity. All analog to digital converters suffer from nonlinearity errors, caused by their physical imperfections, causing their output to deviate from a linear function of their input. These errors can sometimes be mitigated by calibration or prevented by testing. Important parameters for linearity are integral nonlinearity and differential nonlinearity. These nonlinearities introduce distortion that can reduce the signal-to-noise ratio performance of the ADC and thus reduce its effective resolution. Accuracy. An analog to digital converter has several sources of errors. Quantization error and, assuming the ADC is intended to be linear, nonlinearity are intrinsic to any analog to digital conversion. These errors are measured in a unit called the least significant bit. In the example of an 8-bit ADC, an error of 1 lsb is 1 by 256 of the full signal range, or about 0.4%. Dither. In ADCs, performance can usually be improved using dither. This is a very small amount of random noise, which is added to the input before conversion. Its effect is to randomize the state of the LSB based on the signal. Rather than the signal simply getting cut off altogether at low levels, it extends the effective range of signals that the ADC can convert at the expense of a slight increase in noise. Note that dither can only increase the resolution of a sampler. It cannot improve the linearity, and thus accuracy does not necessarily improve. If you want to learn more about networking concepts and definitions, don't forget to press the subscribe button. To be notified when our channel releases another video, click also on the bell icon. And don't forget to visit our website, networkencyclopedia.com.